Welcome back, ladies and gentlemen. Today we are talking about mixed expressions and complex fractions. Doesn't that sound so exciting? Woo-hoo! All right. Well, it is going to be a lot of fun because math is fun. All right, here we go. We're going to get started here, kick it off with a good old-fashioned warm-up. Get your brains going. So you guys are going to take care of this one. Make sure that you remember what we were doing before with our adding of rational expressions. We have 3a over a minus 2b plus 6b over 2b minus a. Go ahead. So let's see how you guys did on this one. So hopefully you guys remembered that anytime you see a grouping, you should automatically put parentheses over those or around those. That way you make sure to keep them a group, all right? Next thing that I notice is that, yeah, I could multiply over here, get these to have common denominators, but I also see that these are opposites of each other. So to make my life a lot easier, what I could do is I could just take out a -1 from here, right? And if I take out a -1 from here, then this would become a minus 2b, wouldn't it? And then I would have the exact same denominator. And then I wouldn't have to go through all the trouble of multiplying and getting big fat denominators on the bottom, and it would be really complicated and everything like that. So now I have this -1, and what do I do with that -1? Well, the easiest thing to do with it would be to move it up there. So now, if I move it up there, -1 times 6b is just -6b. So these have a common denominator, and I have 3a plus -6b. Well, if they have a common denominator, what that means is that technically I can just add straight across. So I have 3a minus 6b all over a minus 2b. Okay, are we done? Hopefully you said no, because what we have going on up top is that they have something in common. I can take out a 3 from up top. So 3a divided by a is a. -6b divided by 3 is -2b, all divided by a minus 2b. And then those will cancel, and I'm just left with a 3. And that should be our final answer, ladies and gentlemen. All right. So real quick, let's just break down what we have done in this chapter and what it entailed before we get into our mixed expressions and complex fractions. So we started off with simplifying, multiplying, and dividing. And when we did those three things, essentially what our steps were we factored everything. We canceled those common factors. We played a game of match is what I like to call it. And then we rewrote them as a single fraction. And remember, we left it in factored form. That is the preferred method. And in fact, when you are assessed on this, you are going to be asked to leave it in factored form. So don't cause more work for yourselves. Leave your answers in factored form. Okay. Then the next thing that you learned was a problem like this, adding and subtracting. So when you did that, you needed to get the least common denominator. And in order to do that, you needed to make sure that your denominators were completely factored. Then you needed to make it into a single fraction, like what we did here. And then once it was a single fraction, you needed to simplify. And these are the simplifying steps. So essentially, right here, once you get to this step, you loop back up and follow those steps. Okay. So now we're going to look at mixed expressions. And mixed expressions really is just following the steps that we have learned already. Okay. So problem number 1 in mixed expression says 5 minus 4 over x plus 2. So we have a whole number minus a fraction here. So you can think of this as 5 over 1 if it helps you. But either way, this and this do not have the same denominator. So this is an adding and subtracting problem. So they need to have a common denominator. And their LCD would be x plus 2. So what I'm going to have to do is on this one, give it the LCD. So I multiply it by x plus 2 over x plus 2. Okay. So from there, I'm going to distribute. So 5 times x is 5x. 5 times 2 is 10. Then we have the minus 4. And it's all over our denominator of x plus 2. And then I combine like terms on top. So 10 minus 4 is 6. So I have 5x plus 6 all over x plus 2. And I don't believe that I can factor anything out of the top. Nothing can be reduced. Don't forget about those restrictions too. So x plus 2 cannot equal 0, which means that x cannot equal negative 2. Okay. All right. I'm going to have you guys try number 2. It's the same thing. Okay, pretty much. Just remember all of our steps that we just talked about here. Okay, so obviously we have an adding or subtracting, mostly subtracting. Okay, don't forget about your parentheses around any groups because that's going to help you from making an error on forgetting to distribute. And then make sure that you factor everything, simplify everything, and state your restrictions. Go ahead. Okay. So let's start off. Parentheses around any groups. There are all of my parentheses. On this one, my LCD is y plus 2. So this one has the common denominator. This one has the common denominator. This one does not. So I'm going to multiply it by y plus 2 over y plus 2. Okay. So then, right here, when I go to distribute, I get y squared plus 2y. Then right here, make sure this is negative, right? So this negative gets distributed to this group. So that's negative 4y minus 4, and then this is a minus 4. And that whole thing is over our common denominator because all of them were over y plus 2. Then I combine all of my like terms up top. So I have y squared, and then 2y minus 4y is negative 2y. Negative 4 and negative 4 is negative 8. Remember, it's still all over my common denominator. I can factor that numerator. So that turns into y minus 4 times y plus 2 all over y plus 2. And we could play a little game of match, and I am left with y minus 4, and then in my denominator I have that y plus 2, right? So y plus 2 can't equal 0, which means y cannot equal negative 2. Okay. Again, nothing too crazy that we haven't seen before. It's just the y didn't have a denominator, so we gave it 1. All right, this one might look a little crazy, but really, if I take away this, it looks just like the problem we just did. Okay, so in fact, that's kind of how we're going to look at this problem. We're going to look at them by themselves first. So even though this says x minus 5x over x plus 5 divided by x plus 5x over x minus 5, we're going to look at each of them individually. So left side, their LCD is going to be x plus 5. So there's a group. So I'm going to multiply this by x plus 5 over x plus 5. So when I distribute, I get x squared plus 5x minus 5x all over x plus 5. And when I combine That ends up canceling, and I just get x squared over x plus 5. That's for the left side. Okay. On the right side, my LCD, there's a group, is x minus 5. So I'm going to multiply this by x minus 5 over x minus 5. And when I distribute, I get x squared minus 5x plus 5x all over x minus 5. Okay. Those cancel. And let me add, this was division, so I'm going to add this division sign right here. So now this whole problem turned into x squared divided by x plus 5 divided by x squared over x minus 5. And if you remember the rules of dividing fractions, you keep, flip, change, or keep, switch, flip, or multiply by the reciprocal, depending on how you like to say it. So I would keep the first fraction, flip the second fraction, and change it to multiplication. Okay. And then from there, x squareds cancel, and I'm left with x minus 5 over x plus 5. And my restrictions are that x cannot equal negative 5 or positive 5, because we've got to look back at the original. Okay. All right. So that is actually a really good problem to introduce complex fractions, because we had a fraction divided by a fraction, which is exactly what a complex fraction is. It just doesn't have the division symbol. It just has a lot of fraction bars. So what we do with all of these fraction bars is we rewrite them with a fraction symbol. So 2/3 over 4/5, we can rewrite that as 2/3 divided by 4/5. Because for some reason, our brains are able to kind of take care of that better than that. That, because it has so many lines going on, we just have a hard time processing it. So now this looks just like the last problem that we did. So we can keep, flip, change, keep, switch, flip. So this becomes 2/3, flip over, change it to multiplication. And then depending on how you like to do this, I like to simplify first. So 2 goes into 4 2 times. This becomes a 1. So 1 times 5 is 5. 3 times 2 is 6. And I get 5 6. All right, you guys are going to try that one. So it says 3a over 4 over 15a over 12. Go ahead. Okay, so first thing is rewriting it. So it's 3a over 4 divided by 15a over 12. Then we do KFC. So it's 3a over 4 times 12 over 15a. And then you can just start reducing. So like 4 goes into 12 3 times. The a's will cancel. 3 goes into 15 5 times. And all that's left is a 3 on top and a 5 on the bottom. Okay. All right. Number 3. 3 obviously looks a little bit more complicated. And it's going to kind of look like the last problem that we did at the top of the paper, okay? So when we rewrite this one, we're going to have 1/6 plus 1/3 divided by 1/2 plus 1/5. So now this looks like that other one with the x minus, what did it say? X minus 5x over x plus 5 divided by x plus 5x over x minus 5, where we just do each of them separately and then we'll bring them back together. So on the left side, my LCD is 6. So I would want to multiply this one by 2 over 2. So this becomes 1/6 plus 2/6, which gives me 3/6. And 3/6 reduces to 1/2. On the right side, my LCD is 10. So I'm going to multiply this by 5 over 5 and multiply this one by 2 over 2. So now this is 5 over 10 plus 2 over 10, which gives me 7 over 10. So now I have 1/2 divided by 7 over 10. And I can do KFC with it. So 1/2 times 10 over 7. 2 goes in a 10 5 times. And it becomes 5/7. Okay. So again, just pay attention, rewriting it, solving them like they're separate, and then bringing them back together when they're all the way simplified, because you're going to try one just like it. So if you need to, rewatch this problem. Okay, you guys are going to try that one. All right, let's see it. So I rewrite it. So first I have 1 over a plus 1 over b divided by b over 2a minus a over 2b. Okay? Then remember, we need to get common denominator. So my LCD for the left side is just AB. So I need to multiply this one by B over B. This one I'm going to multiply by A over A. So I get B over AB plus A over AB. So this becomes B over A over AB. On the right side, my LCD is 2AB. So I multiply this by B over B and this one by A over A. So this is B squared over 2AB. And this is A squared over 2AB. So B squared minus A squared over 2AB. Okay. So now I have B plus A over AB divided by B squared minus A squared over 2AB. Okay. And then that we can KFC. So that becomes B plus A over AB times 2AB. And hopefully you saw that this right here was dots. So that's going to be b plus a times b minus a. And then I see a will cancel a, b will cancel b, b plus a will cancel b plus a, and I am left with 2 over b minus a. Okay. All right. Last one. You guys are going to try number 5. Okay. And try number 5. Go ahead. All right. So this one was just a little different. Actually, it was a lot easier than the last one, but this one turns into n squared minus 25 over n divided by n minus 5, or n minus 5 over 1. That might have helped you if you wrote it like that. Then if we add our grouping, which we should because those are groups, hopefully you saw that this is dots, difference of 2 squares. So I'm going to do KFC at the same time as I factor. So dots becomes n plus 5 times n minus 5 over n. Keep flip change, 1 over n minus 5. And then right here I can place a match. And I'm left with n plus 5 over n. And remember, these n's cannot cancel because this n is attached to the plus 5 and this is not. And that is my final answer. All right, that is all that we have for you folks, and we will see you soon.